All right, so we now know how to predict chemical reactions, but now we're going to determine, in some cases, whether a reaction will actually occur or not. And so most of the stuff will be coming from the purple sheet you picked up. So in decomposition, we know, for example, if I give you NaCl, we know it breaks down into Na and then plus Cl2. So we know that basic compounds will break down, or binary compounds, this is binary because it has two elements, will break down into its elemental components. But what if you have a ternary? So there are different rules, but you don't have to memorize those rules, you just have to know where to look. If you look at the bottom left corner of your purple sheet, on the back side of the periodic table, you'll see where it says decomposition reaction. And this one is what we call a metallic hydroxide. So it's magnesium, which is a metal, and then OH, which is a hydroxide, right? So if you look at it, I think it's number 2. It says some metallic hydroxides, when heated, decompose to form metallic oxide and water. The example given is calcium hydroxide forms calcium oxide plus H2O. So magnesium hydroxide will form magnesium oxide and water. And then you just balance it. I think this is already balanced, so you're good to go. So you just use the patterns that are given to you. So calcium carbonate, that's a ternary compound. How does that break down? So take a look at the example. I think that's number 3. It says some metallic carbonates, when heated, decompose to form metallic oxide and carbon dioxide. So this will form, so calcium is it'll form a metallic oxide, which is calcium plus 2, oxygen minus 2, right? So it'll form CaO plus, and then carbon dioxide, right? And I think this is already balanced as well. And then the last one, it says some metallic chlorates, when heated, decompose to form the metallic chloride and oxygen gas. So this is a metal chlorate, right? So it'll form the metal chloride. So the metal chloride is magnesium. Remember, the magnesium is, and then chloride is Cl2 plus, and then it forms oxygen. So O2, and then I think this one will probably have to balance. Let's see here. This is going to be tricky. I think we have 3 oxygens, and then we'll be good. So we just need to follow the instructions. So number 4 says some metallic chlorates. This is metallic. So this is magnesium your metal. This is chlorate. Form a metal chloride. This is the metal chloride. Magnesium is your metal and chloride. When oxygen gas, which is O2, and then you just have to balance. Okay. So it's not something you have to memorize. It's just when you decompose a ternary compound, just look at the decomposition reactions, and you can kind of follow the pattern that's given there. All right. Some single replacement reactions do not occur. And so remember, in a single replacement reaction, or what happens is one substance is replaced by another substance. Now, the way this only works is if the substance is above on the activity series. So let's do an example. Sodium plus copper to chloride yields what? Well, what we know, first of all, is that this sodium will replace the copper, right? But we look, if you go ahead and look on where it says single displacement, there's an activity series. If you find sodium is maybe the 5th one down, and then copper is pretty far down, right? It's below hydrogen, antimony, arsenic, bismuth, and copper. So sodium is above copper, so therefore it can actually replace it, right? So you get NaCl plus copper off by itself, right? And then you'll have to balance this. But what I want to show you is the reason why this goes, or this reaction happens, is because sodium is higher on the activity series than copper, so it's able to replace it. The second one, we're going to have copper replacing silver, right? So if you look, copper is above silver, right? So it's going to work. Copper is above silver, so this will be... Now, this one we actually have to tell you if it's copper 2 or copper 1 or copper 2. You will not know which copper this is, so I'm just going to say it's copper 1 to make it easy. So copper 1 means Cu plus 1, NO3 minus 1, plus Ag. Okay? Lithium and water. So this one was one we've gone through. Water we can change into HOH. So we want to see, can lithium replace hydrogen? And in this case, lithium is really reactive, so it's going to replace hydrogen. There won't be a problem here. And so we'll have lithium hydroxide with H2. Lithium replaces hydrogen, it bonds with the hydroxide. And then I think you got to balance this guy. This will be 2, 2, and 2. Okay. So just since we didn't have a negative example, let's just say this sodium and copper was flipped. So let's just say I had copper plus NaCl, right? What would happen is copper is below sodium. So what would happen is you would just put no reaction. Like, you don't have to figure anything out because copper can't replace sodium since it's below sodium on the scale or on the activity series. All right, let's take a look at the halogens. So here we're going to see this chlorine wants to bump out the fluorine. However, chlorine is below fluorine, and so there's going to be no reaction because fluorine is higher on the activity series. So chlorine does not have enough energy to bump out the fluorine. Okay? All right. Okay, that's with single replacement reaction. For double replacement, we actually check what's called solubility. So solubility is the ability of a substance to dissolve in a solution. So if it's soluble, that means it dissolves. So salt in water is soluble, so it dissolves, and we call that aqueous. If it's insoluble, it does not dissolve, so we consider it to be solid. So I should also include, this is also called, you might hear the word precipitate. So if a solid precipitates out, that means a solid is not soluble or insoluble. Okay, so the word precipitate is important there. So, how do you know if something's soluble or insoluble? So if you look at your double replacement, there's a chart under double displacement, and it basically tells you what's soluble and insoluble. So, for example, sodium chloride, if you look it up, you see how the second line says in the chart, Cl minus, Br minus, I minus, all chlorides, bromides, and iodides are soluble except for silver, mercury, and lead. So sodium chloride is soluble. Why? Because all chlorides are soluble. So then you say this is soluble. Okay, next one. KNO3. So let's look it up. Let's see if we can find some NO3s. It says NO3, all nitrates and acetates are soluble. NO3, that's the very first line, right? So this means this is soluble. And then PbCl2. If you look up Cl, it says all chlorides, bromides, and iodides are soluble except for Ag plus, Hg2 plus, and Pb2 plus. So here this is lead 2, so this would be insoluble. Okay. So solubility is important for us to know. Okay, so for a double replacement reaction to work, one or more of the following must, so at least one of these must occur in the products. Either a gas is produced, a solid precipitate is produced, so what we call insoluble, or water is produced. So that's one of these three things has to occur for a double replacement reaction to occur. Let's do an example. So BaNO3 Na2CO3. Will this reaction occur? I'm going to do the reaction. So barium's going to form with CO3. Ba is Ba plus 2. CO3 is minus 2, so we're good there. And then NaNO3. Before I balance, I actually want to make sure if this works. Okay, so what I did is I did a double replacement. All right, so I'm going to check BaCO3. So barium carbonate. So if you look at it, it says the fourth chart there, or fourth line, it says all carbonates and phosphates are insoluble except for those with group 1. So barium is group 2, so we're good, and NH4. So this is insoluble, meaning it's solid. So did we have something that was insoluble? Yes. So this reaction will continue, meaning this reaction works. NaNO3, remember all nitrates are soluble, so this would actually be aqueous. But the fact that I have one solid means this will work. And then the next thing I have to do is I have to balance. So just to balance, you would do this. Okay? So we fulfilled one of the three things. What was one of the things? That one of the products was insoluble. Let's look at this one. HCl plus LiOH. Hopefully you realize this is actually what we call a neutralization reaction, because one of your products will be H2O, right? H with OH, and then the other one will be LiCl. Now, what do you need in order for this reaction to occur? Water. Form water, it occurs. So this definitely works. This is already balanced, by the way. Hi plus Li2S. So H will bond with S, right? So you have H plus 1 and then S minus 2. So this will give you H2S plus lithium iodide. Li is plus 1, I is minus 1. All right, let's find H2S. Now, H2S, I already know, is a gas. And if you go down, it's like the second to last star at the very bottom of that chart under double displacement. It says some example of gases are Hofbrinkel, so any of those diatomics, H2S, H2CO3, blah, 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 right? So what I want you to see is H2S, which we made, is a gas. And then lithium iodide, all iodides are soluble except for silver, mercury, and lead. So this is actually aqueous. But we know this works because a gas is formed. That's the third thing. Okay, so I should probably give you an example that doesn't work. Let me show you an example where the reaction won't occur. So let me just make up something real quick. Let's do this. All right, so if I rearrange this is NaCl plus Li2S. Na is plus 1, Cl is minus 1, Li2 is plus 1, this is minus 2, that's why I need 2 lithiums. All right, let's look up sodium chloride. All chlorides are soluble, so this is aqueous. And then if you look at sulfurs, all sulfides are insoluble, except those of group 1 and group 2. Well, lithium is group 1, so it's soluble, so it's aqueous, right? And so since these are both aqueous, meaning they're both soluble, I've not produced a gas, I've not produced something insoluble, and I've not produced water, so there's no reaction. So you could kind of like cross that out and say there's no reaction that's going to occur. Okay? Hopefully that helps.